Welcome back. In our previous lesson, we are talking about solving a constraint in our problem using the substitution method. In this lesson, I want us to talk about the Lagrange multiplier, that is solving a constraint problem using the Lagrange multiplier. Now, what is the Lagrange? We should understand that in mathematical optimization, the method of Lagrange multipliers is a strategy for finding the local maximum and minimum of a function, subject to equality constraint. So we are saying that in mathematical optimization, the method of Lagrange multipliers is a strategy for finding the local maximum and minimum of a function, subject to equality constraint. Now, the best idea is to convert a constraint problem into a form such that the derivative test of an unconstrained problem can still be applied. I know you cannot understand this, but you understand when we start doing the calculations. Okay. Now, the Lagrange function is named after a mathematician, Joseph Louis Lagrange. Is the one that came up with this. I think for us to understand more about this Lagrange multiplier, let's understand this. Okay, we should understand the steps to follow. Number one, multiply lambda with a constraint equation. Now, in Lagrange, there is a Latin, I don't know if it's Latin or Hebrew symbol, that one which you can see here, it's called lambda. So we are going to multiply our lambda with the constraint equation. For example, let's say our constraint equation is x plus y minus 30. So we are going to multiply it by lambda. So if we multiply this lambda by all the elements in this set, we are going to get x lambda plus y lambda minus z lambda. Okay, let's continue. Second, add the formulated function to the objective function. Now we have formulated this lambda, x lambda plus y lambda minus z lambda. So we are going to add this to the objective function. In this case, it is our total cost equation. So we are going to add 2x squared plus 3y squared minus xy plus 10. Then we are going to add this lambda function, which includes the lambda. So it will be plus x lambda plus y lambda minus z lambda. Okay, let's continue. Third step, differentiate the new function in terms of x, in terms of y, and in terms of lambda to form three different equations. So what we are going to do now, we are going to differentiate this 2x squared plus 3y squared minus xy plus 10 plus x lambda plus y lambda minus z lambda. We are going to differentiate of x in terms of x, then we differentiate in terms of y, and last in terms of lambda, which means this now will give us three different functions or equations. Okay, let's see what will happen. Example, we are differentiating in terms of what? That function, we are differentiating it in terms of x. So where it was saying 2x squared, we have differentiated, it is now 4x minus y. Now, here, where it was showing x minus y, we have differentiated 2x squared. We have multiplied 2 by 2, giving us 4. Then 2 minus this power, 2 minus 1, giving us 1, which means it is 4x only. Then there is no x here, so we go to the other one where there is x. So it will be negative x. Remember the power is 1. So 1 times x, it is 1. 1 minus 1, then the x go, we remain with y. Okay, so this is what we are saying. And then here x is with lambda. So when we differentiate for x, x will go just remain with lambda. So this is what we have actually done here. we are saying dy over dx is equal to 4x minus y plus lambda. Now, in terms of y, we have differentiated for x. It is 4x minus y plus lambda. Now, let's differentiate for y. Now, remember that side we had 3y squared. So, when we differentiate 3y squared, we are going to have 6y minus, where it was saying x, negative x minus y will go and will just remain with x. Then where we add y lambda, our y will go and will just remain with lambda. So we have differentiated in terms of y. Next, let's differentiate in terms of lambda. Now remember that lambda is just attached to x plus y minus 30. We add x lambda plus y lambda minus 30 lambda. So here what we are going to do is, all the lambdas will go, because we are differentiating in terms of lambda. We just remain with x plus y minus 30. Okay. Step number 4. Take the two top equations and make lambda the subject. So what we are going to do is we're going to take this equation and this equation, and in each we are going to make lambda the subject. Now what will happen is that these will all be equated to 0. 4x minus y plus lambda is equal to 0. 6y minus x plus lambda is equal to 0. Okay, let's see what will happen. Now, this lambda will remain this side, and when we equate these equations to 0, the 4 will cross the equal sign. That's why it has become a negative. The negative y will cross the equal sign and become a positive. We go in the other function. Lambda will remain. Then 6y will cross the equal sign and will be negative 6y. This negative x will cross the equal sign and it will be positive x. So we have made lambda the subject formula in each equation. Next, the fifth step is that we are going to equate lambda to lambda. Let's see what will happen. So, to lambda. Now, this means that the first equation for lambda, negative 4x plus y, will be equated to this equation, negative 6y plus x. So that's what we have here. Negative 4x plus y is equal to negative 6y plus x. Let's continue. The sixth step. Collect the like terms to form a new function. So, in this equation which we have equated, we are going to collect the like terms. So, negative 4x is going to call the x, which is to the other side, crossing the equal sign. And remember this side, that x is equals, when it crosses here, it becomes, this side, the x was positive, it crosses, it becomes negative. Okay. Then we call this y, 6y. Remember when 6y is of either side of equals, it was negative. It crosses back here, it becomes positive. So our equation will be negative 4x minus x plus y, x 6y is equal to 0. Then here we are going to do the mathematics. How is it going to be? Negative 5x minus x is going to be negative 5x. Then y plus 6y is going to be negative plus 7y, which is equal to 0. What's the next step? The seventh step is to equate the new equation to the third equation you differentiated in terms of x, of lambda. So this equation which you have formulated must be equated to that equation which you formulated, we differentiated in terms of lambda. And we know that that was lambda is equal to x dtc over d lambda is equal to x plus y minus 30, if I remember very well. Okay, let's continue. Negative 5x plus 7y is equal to 0. The next will be x plus y is equal to 30. Now, how are we going to do? We are now going to solve the two equations simultaneously using elimination method. Step you know. So we are going to solve this and this equation simultaneously using an elimination method. Okay, let's talk about this example. So this is the example that we used when we were solving in substitution method. So we have been asked to solve this one using the Lagrange multiplier. Let us close on on the other side and solve this problem. Thank you very much.
Okay, let's do a question in which we are going to solve a constraint problem using the Lagrange multiplier. Now, we are going to consider still the equation we are given in a substitution method in which we are solving a problem involving Busuma limited. Now, the total cost equation TC was 3x squared plus 6y squared minus xy. So that is our the equation which is needed to be solved using the Lagrange multiplier. Now, what we are going to do is this. We are going to take our constant equation, which was x plus y is equal to 18. Now, this constant equation will be transformed to be x plus y minus 18. Right? Then this will be multiplied by a lambda. A lambda is a symbol for Lagrange. Okay. So it will be this multiplied by this, it will be x lambda. This multiplied by this to be positive y lambda. This multiplied by this negative 18 lambda. Then we are going to add this our Lagrange equation, or this is our constant equation with lambda. We are going to add it to this equation. So it will be like this. Total cost TC is equal to 3x squared plus 6y squared minus xy, then plus that's our equation, x lambda plus y lambda, then minus, oh, my choke, 18 lambda. So that will be our new function, our total cost function. Now I want you to follow me very closely because this is where students, miss it. After reaching this point, we have added our lambda equation, our constant equations which have multiplied by lambda. We have added it to our total cost equation. We are now going to differentiate in terms of x, in terms of y, and in terms of lambda, making three different equations. So it will be dtc over dx. We are starting with x is equal to. So we are going to differentiate where there is x, we differentiate. This one will be 2 times 3, it is 6, and then minus 1 there, it will be x, 6x. Now this one doesn't have x, so we bypass it. We go to our next one, which is this one, x. Now we know that the power of x is 1 there. So 1 times x is x, then 1 minus 1 is 0. So our x will be powered to 0. And then number to 0 is 0. So it means the x will go. Just when we fit 1, we have differentiated that one. Then we come to this one that has got x and lambda. So it will be, we are going to differentiate in terms of lambda. We know that it's power 1 there, x. 1 times x is x. Then 1 minus 1, it is 0. Any number to the power 0, it disappears 0. So we just remain with our lambda there. So we have formulated the first equation. We go and formulate another equation, dtc over dy, which is equal to, now we are going to differentiate in terms of y. So where there is y, that's what we're going to consider. So this one is 6y, so it will be 2 times 6, that is 12. Minus 1 there, it will be y. 1y will go. Then minus, this one, our y will go, we just remain with x. Then we'll come here, this, our y will go, we just remain with our lambda. All this should be equated to 0. All this should be equated to 0. The third equation, we are going to differentiate in terms of lambda. We are going to say dtc over d lambda is equal to, we will go in the same equation, differentiate in terms of lambda. Here lambda will go, and it will be x. Here lambda will go, it will be y. Here lambda will go, it will be minus 18. So have you seen what we have done? We have created three different equations. And we are going to solve these equations simultaneously. Okay, let's do it from here. So, I will ignore this equation. I will ignore the equation in which we have differentiated in terms of lambda and concentrate on these equations. Now, what am I going to do? I will rearrange them, make lambda the subject formula. So what will happen is lambda will remain here, then all this will close the equal sign. So it will be lambda is equal to 6 crosses the equal sign becomes negative 6x. This one negative y crosses equal sign becomes positive y. Okay, so we have created lambda the subject there. Even the one for y, the one we differentiated for y, we are going to say lambda will remain here is equal to this 12 will close the equal sign and it will be negative 12y. This will cross the equal sign and it will be positive x. Have you seen what I have done? I have made in all the two equations I have made lambda the subject formula. At this juncture, I'm going to equate lambda is equal to lambda. Which means this equation and this equation should be equated. So I'll take the first one, which is negative 6x plus y is equal to negative 12y plus x, which should be equal to 0. Okay. So now here we are going to collect the like terms. It will be negative 6 is going to call this x, and when it crosses back, it will be a negative. Plus y. This y is going to call this negative 12y, and when it crosses the equal sign, it's going to be 12, positive 12y, which is equal to 0. So let's do the mathematics. This and this, negative 6x minus x is going to be negative 7x. Then positive y plus that is going to be positive 13y. This is equal to 0. So we have formulated an equation. Okay. Now this equation which we have formulated, we are going to solve it simultaneously with this equation here. Okay. So how is it going to be? Let's hope we are following closely. We are going to say this equation is x plus y minus 18. Or let us say x plus y is equal to 18. That one will come as negative 7x plus 13y is equal to 0. Now we are going to solve this simultaneously, where we are going to eliminate one variable. What variable can we eliminate? Let's try to eliminate x. So what are we going to do to eliminate x? I'll put my 7 there. I'll take this 7, put it there. I'll multiply 7 times this is going to be 7x plus 7 times this is going to be 7y. Then 18 times 7. 18 times 7 is equal to what? Cameraman? Is equal to 126. This equation just remains the way it is, negative 7x plus 13y is equal to 0. From there we are going to do the elimination. Now I'm eliminating x. The one is the variable x. So for me to eliminate, what am I going to do? I'll add this. Because if I will subtract, it will be something else. If I add, this and this will go. So x has gone, you're just going to see that. So 7y plus 13y is going to give us 20y, which is equal to 126 plus 0, it is 126. Then we are going to do the division. Because we are solving for x, for y, we are going to divide by y, divide by y, divide by 20, divide by 20 so that we solve for y. This and this will cancel, so y will remain is equal to 20 into 126. 20 into 126 is what? 60.3. it will be 6.3. So just like the way we solved it when we are using substitution method. So we have solved for what? For y. Let's solve for x. To solve for x, we are just going to take our constraint equation. What is the constraint equation? The constraint equation is x plus y is equal to 18. So where there is y, we put 6.3. So it will be x plus 6.3 is equal to 18. We collect the items. X is going to be equal to 18. This will cross the equal sign. And it's going to be minus what? 6.3. So our x is equal to, so 18 minus 6.3 is equal to what? 11.7. So can you see that the answers are correlating? The ones that we solved using a substitution method and the one that we have used the Lagrange multiplier. We got 6.3 when we are using substitution as a value for y. And we got 11.7 as a value for x. So we have proved that what we did using substitution method is the right thing. Thank you very much. Until next time, God bless you.